result, I managed to organise and find funding for a European network of 6 labs called Neuromath, and then a second network of 8 labs called Numbra to collaboratively pursue this interdisciplinary approach. Through the Trieste meeting and the networks, I've been able to meet and discuss and collaborate with an astounding number of inspiring scientists. Stanislas Dehaene was at the Trieste meeting and has been one of the most important shapers of this whole field, and his contribution has been fundamental to my own thinking. No high-class symposium would be complete without a philosopher, and we were lucky that my colleague at UCL, Marcus Jaquinto, was an outstanding philosopher of mathematics and was able to keep us, me in particular, on the philosophically straight and narrow. One student who was in Trieste at that time, but wasn't officially at the Trieste meeting, was Marco Zorzi. He spent some time in my lab doing groundbreaking work on using neural networks to model reading, and later to model basic arithmetic processes. Currently, Professor Zorzi in Padua runs one of the most innovative labs in the world for mathematical cognition. Randy Gallistel and Rochelle Gelman were also at the meeting, where we became friends, and I have since spent many happy hours in various parts of the world, often starting at breakfast, with Rochelle and Randy arguing about the nature of mathematical abilities in humans and other animals. Their approach to these issues, as you will see, has influenced me profoundly. Randy, Giorgio Valatigara, a brilliant animal experimenter at the University of Trento in Italy, and I organised a wonderful 4-day meeting at the Royal Society in 2017 on the origins of numerical abilities that attracted an amazing group of scientists approaching the subject from many different perspectives, from archaeology to insects. 4 days devoted to number, actually 5, because the previous day, Ophelia de Roy organised an international symposium on the philosophy of mathematics at the Institute of Philosophy in London. 5 days on number, I was in heaven. In one sense, this book is an attempt to make the contents of these meetings available to the general reader. Christian Agrillo, from Padua, at the time a student, first got me interested in the numerical abilities of fish. I'm currently collaborating with Caroline Brennan and Giorgio on a project about the genetics of numerical abilities of zebrafish. Tetsuro Matsuzawa, who I first met at a Neuromath Network summer school, invited me to the Primate Research Institute of Kyoto University to observe his inspiring work with chimpanzees. Fundamental to my whole approach has been my work with Bob Reeve on the early development of numerical abilities in mainstream Australia and with indigenous groups there. My work has been supported over the years by many organisations and foundations. The Leverhulme Trust has supported our work with Aboriginal children and our current fish study with Brennan and Valatigara. The Australian Research Council has supported Reeve and me on our longitudinal studies of mathematical development. The Wellcome Trust has supported many of our studies with children, adults and neurological patients. I must say a word of thanks to my literary agent Peter Tallack of the Science Factory. He managed to get the project off the ground after my trying unsuccessfully to do it. I'd been interested in the foundations of mathematics since reading Bertrand Russell in my teens, and in particular Gödel's theorem, when I met, by luck, Diana Laurillard, a student of maths and philosophy, by gatecrashing her bonfire night party in 1967. Despite the brief interruption of a police raid, I learned that she was also interested in Gödel's theorem. The other piece of luck is that Diana remained interested in my work and in me until the present day. We now work together on how to turn evidence from the science into practical applications in education. She also patiently listens to and corrects my ideas. So some of the errors in this book have escaped even her close scrutiny. Chapter 1. The Language of the Universe. Galileo, 1564 to 1642, said that the universe is written in mathematics.